point of this lecture is to go over the material for chapter 11, kind of like I would do in class, and go over the pre-exam 2 material. So you can see if you go to the Blackboard homepage, grab this link, this video. Post this real quick. That is being recorded right now is available on that link, and then also a blank pre-test. So if you did not get a copy of pre-test 2, you can find that here, and then the answer keys to the pre-test 2 are attached here. So I had a couple students email me some questions. One student emailed me a question from chapter 11.1, and we talked about this one in class. I'm just going to go over it again. How many different ID cards can be made if there are 6 digits on a card? No digits can be used more than once. So if that was part A, this is the definition of a permutation. So I have 10 digits, and I want to find the permutation of picking 6 of them. Now you don't have to do it that way. You could say, use the fundamental counting principle for part A and say I have 10 options for my first digit, 9, 8, 7, 6, 5, and get the answer there. B is saying, what if the digits can't be repeated? Well, B, you can't use combination or permutation because combination and permutations only work if the digits can only be used once. So here you just have to think I have 6 digits and each of them have 10 choices. So the answer is going to be 10 times 10 times 10 times 10 times 10 times 10, or 10 to the 6th power. So hopefully that answers any questions on that. I had some just in general on 11.6, and we went over all these in class on 11.6, so I might suggest you, if you have questions on 11.6, to go back and watch that lecture over 11.6, and you can easily do that in Blackboard if you click the lecture link to the recording, and you can actually skip towards the end where we go over the homework problems. So 11.6 is telling the difference between a probability and an odd. So if you have A over B is the probability of A happening, then the odds of A, the odds for A, let's say the odds for A is going to be A to B minus A. An example, if I say what's the probability of getting a heads on flipping a coin, that's going to be 1/2. If I say what's the odds for a head, it's going to be 1 to 1. There's one head and there's one that's not a head, which turns out being tails. Another example is the probability of rolling a dice and getting a 1 is 1/6. The odds for getting a 1 on a dice would be 1 to 5. And then of course you can go from odds to probability. If you're given the odds are A to B, then the probability for it is A over A plus B, and the probability against is going to be B over A plus B. If the odds in favor are A to B, then the probability for it happening is A over A plus B, and the probability of it not happening, or the probability against it, is B over A plus B. So that's just kind of a quick recap of 11.6. Now I want to go to the answers to the pretest 2, And generally in class, you know, I kind of walk around and see, you know, where you're struggling at, but the answer key is posted online, and I'm just going to walk you through the whole pre-test too, since we didn't have an opportunity to meet in class today. So if it says show your work or show you the formula, that's an important part of the problem. So the first step, I want to show my work, and showing your work here is saying, okay, I'm going to take 520 times 519 times 518 factorial divided by 518 factorial. That's going to simplify, and I'm going to take 520 times 519 and get 269,880. You can definitely check yourself by plugging that in your calculator, but this is the kind of work I want to see how this 518 cancels on top and bottom there. The definition of permutation and combination. So the definition of permutation here is 10 factorial over 10 minus 3 factorial. That is the formula I want to see. Then that can be simplified to 10 factorial divided by 7 factorial, which is 10 times 9 times 8 times 7 factorial divided by 7 factorial, which ends up being 720. Again, you can check yourself with your calculator, but I want to see the formula. Clean this up a little bit. The combination formula would be 10 factorial divided by 10 minus 3 factorial times 3 factorial. So I get 10 factorial over 7 factorial times 3 factorial. So I end up with 10 times 9 times 8 times 7 factorial divided by 7 factorial times 3 factorial, which actually gives me 720 divided by 6, which gives me 120. So you need to know the permutation formula and the combination formula, and then you can plug that in your calculator to confirm that you've done those steps correctly. Some of the students were asking, you know, is there going to be a lot of probability on this test? And there might be questions that are asked, how many different ways are there to do something? Or I might say, what's the probability of it happening? So this next example is just asking how many different ways something can happen. A specific thing can happen, right? So in this example, I'm selecting 3 applications for teaching positions from a pool of 20. So the order doesn't matter, so it's a combination. So I said 20, choose 3. This is not a probability question. I'm not saying what's the probability that all 3 of them are female, which would be the same type of problem, except that I would have to find how many ways that specific event could happen, divide by this number. This is the total number of ways I can select 3 different applicants from a pool of 20 applicants. So here I could pull in the formula. It's not necessarily important here though, because I didn't say you have to use the formula, so you could use your calculator. The key thing is to know it's a combination instead of a permutation. So simplifying this, I get 20 times 19 times 18 over 3 factorial, and that gives me 1,140. So we'll see an example where we actually go into the probability on number 4, and I still have to calculate the total number of ways. How many ways can you rank 2 out of the 5 student essays? I'm ranking them. So I'm ranking first place and second place. So if I have, this is a permutation, because order does matter here because I'm ranking them. So this is a 5 factorial over 5 minus 2 factorial. Again, the step-by-step formula is not what is graded here. Really, on this question, it's asking, can you identify it's a permutation and not a combination? Because the order matters. Anytime you have rank, order matters. Now, sometimes in probability, I'll ask you to put your answer to 3 decimal places, and that's just so I don't have to worry about people reducing fractions properly, and I can just look at the answer in the decimal places. So this example is an application of the probability. So similar to the one we did above, number 3, number 4 is listed twice, but so we have a shuttle mission consisting of 3 men and 1 woman. 2 of them are selected at random for a spacewalk. What's the probability that a woman is included? Right. So in this example, there's only 1 woman. So I want to know what's out of 3 men and 1 woman for a total of 4 people. If I'm picking 2 of them, what's the chance that 1 of them is a woman? So 1 woman and 1 man. So 3 choose 1 times 1 choose 1 over 4 choose 2. So you can see here, I'm not necessarily testing, I'm testing a combinations of things. This is the number of ways to pick 1 man. This is the man. This is the number of ways to pick 1 woman. And then I get 3 times 1 over 6, which would be 3 over 6, which is 1/2. So the probability here, if I want to round that to 0.5, so this is just generally express your answer rounded to 3 decimal places. If it only is 1 decimal place, don't worry about that. That's just a general thing for the question. It might, later on you'll see where we round them to more than 1 decimal place. So probability, we have to take into account the total number of ways to pick 2 people from 4. Number 6, how many ways can a person select 4 books, 2 CDs, and 1 DVD from 10 books, 20 CDs, and 5 DVDs? This is not a probability question. This is just how many ways it can happen. So if I take the category books, CDs, and DVDs, I have 10 books to choose from, and I want to know, I'm picking 4 of them. I have 20 CDs, and I want to know how many ways I can pick 2 of those. And DVDs, I have 5 DVDs, and I want to know how many ways I can pick 1 of those. So 10 choose 4 is 210, 20 choose 2 is 190, and 5 choose 1 is 5. So using the fundamental counting principle, looking at the different categories, multiplying them together, I get 199,500. Those are the different ways I can make that happen. If I want to know what's the probability of this happening, then I would divide that number by, what is there, 10, 25? So 35. 35 choose 4, 5, 6, 7. That would be a probability. But here I'm just asking how many ways it can happen. So how many ways it can happen would be this answer here. So be sure to carefully read the problem and know, are you just doing how many ways it can happen, or are you doing the probability that it happens? So dice is rolled 1 time, find the probability of getting a number less than 4 or an even number, right? So if I write my sample space I have 1, 2, 3, 4, 5, 6. Out of those 6, I have 1, 2, 3 is less than 4, and 4 and 6, and I'll go ahead and put 2 there, are even numbers. So if I want to know what's the probability I get a number less than 4 or an even number here, call that event E. Probability of E happening is going to be 5, 6. You could do the math and say 3 out of 6 plus 3 out of 6 minus 1 out of 6, where they overlap. Right? This is the probability of getting a number less than 4 plus the probability of getting an even number minus the probability of both happening. And we get 5 out of 6. You can see that here, or you can use the formula. A box contains 3 $1 bills, 2 $5 bills, 4 $10 bills, and 4 $20 bills. What is the expectation if one bill is selected? So this is an expected value problem. So the expectation would be the probability of getting the $1 times 1, plus the probability of getting the $5 times $5, plus the probability of getting the $10 times $10, plus the probability of getting the $20 times $20. Here you're not paying anything to play, so you don't have to worry about losing any money or whatnot. But here we would get that the expected value is $10.23. Here's an example of looking at odds and converting it to probability. So we want to know the probability. If the odds are in favor of the event are 5 to 3, what's the probability the event will occur? The event will occur. Probability the event will occur, given that it's in favor, is going to be 5 over 5 plus 3. 5 over 7. Ooh, 8. 5 plus 3 is 8. So knowing that the odds against it in part B, the odds are against in part B, the probability that the event will occur are 9 over 9 plus 2, which is 9 over 11. This is a 2 dice problem. So if I take a minute and write out that table, I'm looking at the sums. And this is the first dice, this is the second dice. Find the probability of getting a sum of 8. The probability of getting the sum of 8. How many ways can I get 8? 1, 2, 3, 4, 5. So this would be 5 out of 36. And that is your answer there. The probability of getting a sum of 2 or 6. So getting a sum of 2 or 6. So there's 1, 2, and there's 1, 2, 3, 4, 5 6s. So that would be 6 out of 36. And that would be reduced to 1/6. Highlight those. There are 6 out of 36 2s or 6s. The probability of getting a sum greater than 7. Greater than 7 would be everything in this region. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So my answer here is 15 out of 36, and that can be simplified to 5 out of 12. The next two examples are the odds of something happening. The odds of getting a sum of 10. So getting a sum of 10, there's 3 of them. So right, there's 3 ways to get 10. And then there's 33 ways not to get 10. Right? This would be 36 minus 3. That would be 3 to 33, or I could write that 3 to 33. That simplifies the 1 to 11. I can write that as 1, 11, or 1 to 11. So hopefully that is clear there. The odds against getting the sum of a 5. So I want to know against getting the sum of 5. So how many ways? 1, 2, 3, 4. There's 4 ways to get a 5. So 4 ways to get 5. 36 minus 4 would be 32 ways not to get a 5. So I want to know the odds against getting a 5. That's going to be 32 to 4. 32 to 4. That would simplify to 8 and 1. Number 11 here is asking, given this table, find the probability of each of the following. The student did not answer the question, right? Student did not answer the question. Well, 2 students didn't answer the question. So here we have the total, how many students we have. We have 10 boys and 8 girls. So we have 18 total students. And if I also look at the total here, I have 2 people didn't answer the question, 3 people said no, and 13 said yes. So how many students did not answer the question? 2 out of 18. And I can simplify that to 1/9. The student is a girl or answered no. So here, the probability that it's a girl or answered no would be how many girls I have? 8, right? 8 over 18 plus how many people said no? 3 out of 18 minus the number of girls that said no, which would be 2 out of 18. So that would give me 8 plus 3 minus 2 would be 9 out of 18, which would be 1/2. You could also go to the table and say the girls plus the no's, and then take 5 plus 2 plus 1 plus 1, and get the same kind of approach there. The student is a boy or answered yes. Right? So the boys and then the number that answered yes. So 8 plus 1 plus 1 plus 5 over the total of 18. So that's 15 over 18, which simplifies to 5/6. Here's some examples where this 3 decimal places come in handy. Find the probability that I pick 2 cards from a deck, that I don't replace them. What's the probability that both of them are kings? So I get a king and then a king. Is not replaced. So first I start out with 4 over 52, and I can write that as 1/13. Then I multiply that by 3 out of 51. Your calculator, you should be able to put that in. It simplifies to 1 over 221. This is why I want the 3 decimals. If you plug that in, you get 0.04525, which is 0.005 if I round 3 decimal places. So find the probability the first card is a spade, the second card is a diamond. So we want the first one to be a spade, the second one to be a diamond. So we have 13 out of 52 times 13 out of 51. Multiply that, we get 13 out of 202. Sorry, 204. Simplifying, 0.06375, and that goes to 0.064. So this just makes it a little easier for me to grade because everyone's going to get the same 3-digit place versus if you take 13 times 13 and 52 times 51 and then try to simplify it, it can get messy. So be careful if it's being replaced or not being replaced. Single card is drawn from a 52 card deck. Find the probability of getting a diamond or a queen. So you're only drawing one card, right? So there's 13 diamonds out of the 52 cards, plus the 4 queens out of the 52 cards, minus the 1 queen of diamonds, which is 16 out of 52. Probability of getting a heart or a 3, 13 out of 52 hearts, plus, oh, sorry, this is not or. Probability of getting a heart and a 3. Key there, a heart and a 3. 1 out of 52. There's only one card. 1 3 of hearts. So be careful with that. Sally's freshman orientation. This is going to be very similar to the ones we did in the first page and second page. We're looking for the probability that the selection will have 2 computer science majors, 1 electrical engineer, and 1 architectural major. We know there's 6 computer science, 4 electrical engineers, and 3 architectural majors in her group. So if they pick 3 people at random, what's the probability that you end up with, oh, they're picking 4 people, sorry. 4 students are selected. 2 from computer science, 1 from electrical engineering, and 1 from an architectural major. So if you just put your boxes and kind of set it up over your total, you can get your probability by going about that. So if I want to know 2 computer science, if this is my computer science, if this is my electrical engineering, and this is my architecture. From computers, there's 6 available, and I'm picking 2 of them. There's 6 computers available, I want 2 of them. There are 4 electrical engineers available, I only want 1 of those. And there are 3 architectural engineers available, and I want 1 of those. Out of the 13 total students, choose 4. So 6 choose 2, 15. 4 choose 1 is 4, 3 choose 1 is 3, divided by 715. And that gives me 180 over 715, which simplifies to 36 over 143, which is 0.2517. Don't be afraid to put it in decimal. That's fine. I want to see the other work, of course. But if you end up with a decimal, that's fine there. So that was the last on the study guide. Some of the ones you know, that maybe didn't come up would be kind of the conditional. There was no conditional. If you look back into, you know, what's the probability that a boy did not answer the question? And that would be 1/2, because you would think here the boy that did not answer the question. So if they say, what's the probability a boy did not answer, given the person did not answer the question. So if it says given that, that kind of tells you it's a conditional. If I said given that it's a girl, what's the probability they didn't answer the question? Given that it's a girl would tell you it's in the girl category. The probability they didn't answer the question is the number of people that didn't answer the question that were girls divided by the total number of girls. So be very careful with the given that conditional. And that really wasn't on the pre-test. If you guys have any questions, please let me know. I'll kind of be checking my email, and I will try to be in the classroom maybe 30 minutes before the test. If you have any questions, you can come a little early if that works in your schedule. Best of luck. Enjoy your snow day, and keep me posted.